Hello everyone, this video covers about information theory. Before we begin, can you guess the word in this picture? And the answer is information. Information is the source of a communication system, whether it is analog or digital. Or in a simpler definition, whatever two people are discussing is there is information that is being exchanged. In 1948, Claude Shannon wrote a paper at Bell Labs. He defined in mathematical terms what information is and how it can be transmitted in the face of noise. What had been viewed as quite distinctive modes of communication that we use today, telegraph, telephone, radio, television, were unified in a single framework, which is now known as the information theory. Claude Shannon was also known as the father of information theory. Information theory is a mathematical approach to the study of coding of information along with quantification, storage, and communication of information. Information theory overlaps heavily with communication theory, but it is more oriented toward the fundamental limitations on the processing and communication of information and towards the detailed operation of particular devices. In this theory, entropy can be defined as a measure of the average information content per source symbol, such as the equation shown here, where the pi is the probability of the occurrence of character number I from a given stream of characters, and b is the base of logarithm used. Hence, this is also called Shannon's entropy. The of Claude Shannon's information theory has been used in vast ways, such as in data compression. Shannon's concept of entropy be used to determine the maximum theoretical compression for a given message alphabet. In particular, if the entropy is less than the average length of an encoding, compression is possible. Example are zip files, MP3, and Jhopete. Cryptology. Cryptology is the science of secure communication or the study of how information is concealed and encrypted in the first place. In particular, he began his analysis by noting that simple transposition ciphers, such as those obtained by permuting the letters in the alphabet, do not affect the entropy because they merely relabel the characters in his formula without changing their associated probabilities. Physics. The term entropy was originally introduced by the German physicist Rudolf Clausius in his work on thermodynamics in the 19th century. In certain formulations of statistical mechanics, a formula for entropy is derived that looks confusingly similar to the formula for entropy derived by Shannon. One of Shannon's key contributions was his analysis on how to handle noise in communication systems. Noise is an inescapable feature of the universe. Much of the noise that occurs in communication systems is a random noise, often called thermal noise generated by heat in electrical circulation capacity. In electronic communication channels, the information capacity is the amount of information that can pass through a channel without error. The information capacity of a channel is the amount of information that can be passed through a channel in a given time period. It is intimately related to the bandwidth of the channel because the faster the signal can change, the more information that it will be able to carry. Let's discuss the Shannon limit on information capacity. In 1948, Claude Shannon also explained that any channels of communication could be characterized by two factors, bandwidth and noise. Bandwidth is the range of electronic, optical, or electromagnetic frequencies that can be used to transmit a signal. Noise, on the other hand, is anything that can disturb that signal. Given a channel with particular bandwidth and noise characteristics, Shannon showed how to calculate the maximum rate at which data can be sent over it with a zero error. In information theory, Shannon's noisy channel coding theorem states that it is possible to communicate over a noisy channel with arbitrarily small chance of error when the rate of communication is kept below a maximum, which is constant for a channel. Known as Shannon's channel coding theorem, concerns the possibility of communicating via a noisy channel with an arbitrarily small probability of error. Its proof is based on the random coding argument, perhaps the first occurrence of probabilistic method. This has now been known as the Shannon limit on information capacity. For Shannon limit on information capacity is expressed as C is equals to B log 2 1 plus S over N. Now, C can be sometimes denoted as I, and B stands for bandwidth, and can also be explained as signal to noise ratio, where S is the average transmitted signal power while the N is the average noise power. Unit for the Shannon limit on information capacity is bits per second, or BPS, are one of the simple examples of Shannon limit on information capacity. In the first example, a system has a signal to noise ratio of 2570, or 30 decibels, and a bandwidth of 1900 kHz. What is the Shannon limit for this system? Now first, we must identify our givens. We have a bandwidth of 1.9 kHz and a signal to noise ratio of 2570. Now we know that the formula is C is equals to bandwidth log 2 1 plus signal to noise ratio, or shown here as S over N. Now we input those. It becomes C is equals to 1900 Hz log 2 plus with 1 plus 2570. The answer is 21.52 kbps. That the Shannon limit for this given system is equals to 21.52 kilobits per second. For our second example, consider the old landline telephone communication system with a bandwidth of 3100 Hz. The telephone system is generally assumed that to acquire a SNR of at least 3126 to operate without unacceptable bit errors. Calculate the maximum channel transmission capacity as predicted by the Shannon equation. Now, as you can see, the maximum channel transmission capacity is denoted as C, which also means the Shannon limit on information capacity. Now let us find our given. We have a given of bandwidth of 3100 kHz while a signal to noise ratio of 3162. Now let us put this in our equation. Now we know that our formula for Shannon limit on information capacity is bandwidth times log 2 1 plus S over N, which also means signal to noise ratio. Now as we input these values, it becomes C is equals to 3100 Hz log 2 1 plus 3126. The answer for this is C, or Shannon's limit on information capacity C is equals to 36.04 kilobits per second. And this means that the Shannon equation shows that the maximum channel transmission capacity is 36.04 kilobp. The applications of Shannon limit on information capacity is vast, such as in economic markets by considering an established aggregate economic model and several of its variants as information channel. It shows that Shannon's coding theorem, or the Shannon limit on information capacity, allows one to precisely define the sense in which information is transmitted by an economic market. Unique to economic markets is the structural existence of a noiseless feedback path from the channel output, the market clearing price to the channel input. Market trader bids and offers which simultaneously account for source information and market clearing prices. Known results in information theory are used to show that economic equilibrium occurs when market agents can predict the market input information from the price observations with arbitrarily small error probability. The agent signaling rates achieve channel capacity in this instance. Also, industry that requires information sharing. Why? Because it shows that there exist good codes with exponentially small probability of error for long dock-length communication. Hope you learned something new. This video is presented by Rambuyon Christian Jhopete.